Hello, I'm Lyuben and I'm a penetration tester here at AMATAS. SQL, or SQL, is a language that allows us to extract information from databases. SQL Injection is a vulnerability that occurs when user-supplied input is embedded directly in queries to the database. To understand this concept better, we first need to understand what relational database management systems are. A database management system allows for storage of information. Let's say we want to go to an arts exhibition tonight. We navigate to the event management website and we search for events in the arts category. We search specifically for the word exhibition in the title. The application takes our input and embeds it in the SQL query. The database management system processes our query and returns a result. It found an exhibition that matches our criteria. What is the problem here? When the user input is embedded directly in the SQL query without any form of sanitization or validation, this opens the door for attackers to change the logic of the query and extract information from the database that they normally wouldn't have access to. Now let's see the injection in action. We have opened the event or event management website in our browser. We can look for events in any category here. We choose the arts category to look for an interesting exhibition tonight. We see two events here. Now let's see what happens if we perform a simple SQL injection. We use the URL search bar to type in or 1 equal to 1. This injection will change the logic of the query and show us all available events, not only those that we would normally see. As a result, we're now able to see different events that were previously hidden from us, including a hacker conference that's for VIP-only members, as well as a private security briefing that's an admin-only event. Now let's try to open one of these events. We'll notice that we don't have access to it. As a normal user, we don't have access to this content. However, let's try and perform another SQL injection, very similar to the first one. As we can see, the injection yielded results. We can now see the private event and we can see that it's for VIP or admin users only. Once again, we were able to change the logic of the query. Let's analyze what just happened. This is the query that the application makes to the database. As we can see, the query shows the results only if the condition is VIP only is false. Or in other words, the query returns only those results that are not VIP only. Since we are not a VIP user, we cannot see the event. Now let's analyze what our injection does. Essentially, it makes the condition in the where clause evaluate to true, because 1 is always equal to 1. And as a result, the VIP-only condition does not matter anymore. The double dash is a comment and we use it to comment out the original, now redundant single quote character, such that our query is correct. So far, we were able to change the query logic and extract more information from the same table, the events table. However, databases usually contain tens or even hundreds of tables that often contain information like user emails, usernames, even passwords. Let's try and see if we can use SQL injection to extract the administrator password from the users table. This time, we will perform what's called a union-based injection. To do so, we need to use the union select keyword and then select the fields that we are interested in. Let's select null for the fields that we do not know, and then let's select username, email, once again we use null, and password. Now we need to specify the table that we're going to extract the information from, so let's do that. Let's use the users table from users, and now we need to specify a user that we're interested in. Let's use the administrator because that's the most highly privileged user. We say where username equals admin, and then we use the comments to ensure that the query structure is not ruined. And we can see in the results that we now have the username, email, and password of the administrator user displayed on our screen. Now let's analyze what happened here. We use the special keyword union that allows us to combine results from different tables. As such, we combine the results that were normally returned by the query with the results from our injected query, which returns the email, username and password of the user with username admin from the users table. Once again, we use the comment, the double dash, to comment out the rest of the original query and make sure that the query structure is not ruined. Now that we've seen how a SQL injection works, let's talk about how to stop it. The root cause here is that the user input is being injected directly into the SQL string without any validation, sanitization or safeguards. First, let's look into the code that allowed us to perform a union-based injection and extract the admin's password and fix it. As we can see, the user input is injected directly into the query via the category parameter. To fix this, we will use parameterized queries, also known as prepared statements, to fix the code. This ensures that the input is treated as data and not as executable SQL. Here is how that looks. Let's analyze what's happening here. As we can see, we're using placeholder values, noted by the %s sign, and not embedding the input directly into the query. This ensures that even if someone is to inject SQL, such as 1 = 1, it will be treated as a literal value, not as executable SQL. Finally, Flask executes the safe, parameterized query with the user-provided values. This is the core protection. By using this, the SQL driver safely escapes and binds parameters, removing any chance of SQL injection. By using parameterized queries, we can see that the injection that previously allowed us to view the admin's password no longer works. The query simply returns no results. If we check the SQL logs, we can see that the query that was actually performed. And, as we can see, all dangerous characters like single quotes have been escaped. Let's fix the other injection point as well. This is the vulnerable code that we exploited earlier to view the contents of the VIP-only events. As we can see, the user input passed via the event ID parameter is embedded directly into the SQL query. To fix the vulnerable code, we'll use a different technique, typecasting. If you expect a number, cast it or validate it before using it in a query. By using this technique, if an attacker attempts to supply a single quote, space, parentheses, or any other character that is not a number, an error will be raised before attempting to perform the SQL query. Let's see if we will be able to view VIP events now that we have fixed the SQL injection and see what happens. So as before, we don't have access to VIP events. However, if we try to perform the SQL query now, we'll see that we get an invalid ID error. The reason for this is because the application is expecting an integer and it's crashing because we have spaces and other characters in there that it does not allow. The typecasting technique prevents someone from passing a malicious string like or 1 = 1 because we require a valid integer before even running the query. This type of remediation is not foolproof, but it adds another layer of security and is perfect for quick fixes. To ensure your application is safe from SQL injection, follow these practices. Always use parameterized queries. Validate and cast input types where possible. Avoid dynamic SQL unless necessary. Make sure database accounts have the least privilege. Thank you for watching this video. Stay safe and vigilant.